In this video we learn how to do some raster data analysis. We'll learn about some of the raster data analysis tools we have in GIS. First, let's see what analysis options we have for the DEM. As shown in the manual, let's first add the DEM file, DEM image. Open the arc map and go to add data, DEM mirror image, add. What if you want to convert the DEM pixels values to feet, because these are in mirror? How can we do that? We can simply go to Raster Calculator, and go to image times 3.2808 and OK. If we press OK, then we'll have the image, but let's also select the output raster, right? Let me just go to output and create a new folder. I'll call it Raster Analysis output. Okay, and there I will save as DEM feet. Save. Now let's also change a few things. We don't want to change the value of this whole DEM. Instead, what if we want to just change perform actions within a masks within our study area? For that, we need to add our study area. So let me copy it, because I don't think we can. Oh, we can. Okay, just click the add data and go to mask the shape and add it. So that is going to be our study area. We want to perform within that environment, within that boundary. So go to environments, workspace. You can change it to whichever is your workspace. Mine is Raster Analysis. Okay, add, and that's workspace. Now processing extent, let's use it. Same as layer mask, same as the mask layer we want it to be. And go to Raster Analysis. There we'll select minimum of inputs, and mask, let's change it to the mask shapefile mask. And okay, so that should be it. Let's see, it's done already. As you can see, we have the values converted to feet, and also it's only within our study area. Now let's see how we can symbolize these things, just for practice. If you double click that or go to properties and go to symbology, you have many types. Classified is mostly used. If you want to classify to 5 classes, we can just use that and change the color ramp, apply, and see. You can see the classes, how the value ranges. Also, if you see that, it's just different ways to visualize things. We'll be using those in later exercises. So it's just an exercise of what can be done. Now let's go to this exercise 1.6, how we can use relational operators to select pixel following the criteria. Let's first add the elevation layer and ownership layer. Add data, Raster Analysis, ownership layer, add. You can see an exclamation mark there. That means there is a problem there. So if you go to properties, general, source, the path is wrong, so we click select set data source and ownership image, add. Okay, let me zoom to layer. That should work. Let's also add elevation layer. elevation, add, properties, source, set data source, elevation data image, add. Okay, we have those layers added. Now what we want to do is go to arc toolbox, Spatial analyst tool, logical, greater than and equal. We want the area of our elevation. We want to extract only the pixels from our elevation layer which has the height above 2400 meters, right? So what we're actually doing here, which location is suitable for plantation or planting of trees or not. So let's first do this. Height above 2400 meters, right? So we have various data there, but we want to extract the one thing, right? So let's go to toolbox, system toolbox. It should be in analysis tools, I guess. Nope, that's not where we find it. It's in Spatial analyst tools, right? GS Spatial analyst tools, and we have math, logical, greater than, right? So we want the values greater than or equals to 2400, so we'll go greater than equal. We're working on the elevation layer, 2400 meters, right? Constant value greater than or equals to 2400 meters. Let's save the file to our output folder. We'll name it, what should we name it? Good elevation. Okay, good. Now before you press OK, there's something to keep in mind. That is, we had changed the environment to the mask area, right? Do you remember that? The processing extent. So instead, we don't want that to happen. We don't want that to happen because the mask area is in another location. So let's remove the mask area. Okay, and processing extent should be, let's just set it to the default. Okay, press OK, and we should be good to go. Done. So there you can see zeros are the one which does not match the criteria, that is, which are below 2400 meters, and green is the one which matches the criteria. So these are suitable area for plantation. But that's not the only factor. We also have another factor. The forest area should be a forest area, right? We cannot just plant the forest anywhere. The ownership should be a forest area, and that is 200, right? So how can we do that? We can do that by using the equal to tool. Let's go to the toolbox, logical, equal to. Ownership should be equal to 200, right? Yeah, ownership should be equal to, the value should be equal to 200. If you go to properties, then you can see that the symbology, you see these have the value like 100, 200, 300, 900. So 200 is the one that has the forest area. Let's save the output. What should we name it? Okay, let's see. Good own. Okay, that's good. Good own means good ownership. Save, and okay, done. So we also have the good ownership data, right? But where is it? uh, Seems like we have messed up a little bit. Let me remove it and do that again. We might have forgotten to change the environments, right? This might be taking the old environment. Sorry, not elevation, it should be ownership 200, and good elevation 1, or let me just remove the good elevation first and then name it that. Okay, I removed the good elevation from my files, and we can save environments. Let me check the environment. Processing extent, it should be default, and Raster Analysis. Oh, okay, I want to remove the mask. If you don't want to do this again and again, you can just change it from here, geoprocessing environments, that this is a master control. So processing extent, default, Raster Analysis. Let's remove the mask. We don't currently have a mask for this area, that's why I have to remove the mask. And press OK. Now we're good to go. Let's press OK. Failed to execute. What did I change? Environment, processing extent, default, Raster Analysis. We don't have a mask. Minimum of inputs. Okay, it worked now. It just did not work because I was changing from two locations. After we have both the data of good elevation and good ownership, we're going to combine those data, because we can plant trees only in the place where both conditions meet. So we'll go to logical and choose the Boolean and so we have good ownership and good elevation. We'll select both, the condition where both it's suitable for both. So good farm, and okay, close. So as we can see, this is the location where we can plant. The green is the part where we can plant, and brown, the black or brown, is where we cannot plant. Now so so far we have only seen the suitability using elevation and ownership, but there can also be variation due to the soil type. How can we do that? We'll see two methods. First, by using combinatorial AND method from the ARC toolbox. Let's first add the soil layer. Soil layer add. We again have the issue with data source, so we'll set source soil image add. Okay, this is our soil type layer. Now we'll go to ARC toolbox, Spatial analyst, logical, and the combinatorial AND. So combinatorial AND. Okay, there we will is soil and good farm. We also see how these are different, the first and second method. So first use combinatorial and let's save as farm soil. Okay, done. So this is the farm soil layer. As you can see, let's see the attribute table. Oops, I should not have removed it. Okay, let me add it again. Farm soil. Yeah, I wanted to see the attribute table. As you can see in the attribute table, it has assigned unique values to different combinations possible. This means that even in the suitable land from perspective of elevation and ownership, different combinations exist. One may choose which one to use for plantation now. So for each combination, we see different, it has categorized it. So soil is 201 and 1, it's one category. So each unique combinations have different categories, right? Now let's use the second method, how we can do that. If you see the manual in older versions of ArcGIS, we had a different raster calculator where you could use combine function, but now in the newer version instead we have a combine special analyst toolbar instead. So use that, go to search and write combine and select the tool, then select the input rasters, which is soil and good farm. We'll name that farm soil but combined, right? Farm soil com. Save. Okay, and this should work. What's the difference between those two combinations? Let's see them side by side. We have farm soil, okay, we cannot separate it, seems like. Okay, so in the attribute table, if you look closely, if we use the combinatorial and, we see we have each combination and we have the count, how many exists. But in the farm soil combination tool, we have each combination, each different combination with 0 and with a good farm and soil, we have them differently and we see their count. But here if we see zeros and zeros, everything's shown in one place, right? So in summary, it means the combinatorial and, this one, the combinatorial and includes all categories with 0 in one of the inputs as same categories. If one input has 0, then it's all added in the same row, right? But in farm soil combination, we have unique, it combines and considers all combinations possible and place them differently. Even if good farm is 1, if soil is not 0, then it's considered a different combination. But in farm soil, if any one of them is 0, then it's considered as one combination, because 0 is just not suitable, only ones are. So that's the main difference between those two. We can also limit our processing within the pixels, those satisfying certain conditions, instead of processing them processing the whole region, consuming our system resources. We can do this by using mask. So mask has value 1 on the area where it is supposed to process and 0 in the remaining area. For example, we can extract the area which soil type is other than water, and the ownership type is equal to 200, then we'll create a mask of those area. How can we do that? Let's turn off all the layers except the ones we need. Those are soil and ownership layer. So right click here and turn all layers off. Now also collapse all layers so it's easy to see. Just turn the soil layer and the ownership layer. Okay. These are what we need. We want only the area that is other than water area, right? So this is the water area, this other than water area, and ownership should be equal to 200. So that's our condition to create a mask. For that, we can again go to the Raster Calculator. Raster Calculator. So we already have our Raster Calculator open. Now let's write an expression. Set now if soil is equals to 901, or if ownership is not equals to 200. So that should be 1. Let's save the raster as our soil masks. Press OK. Now there we go. We have our soil mask. Now in our next step we will remove all non-essential portions by extracting the farm soil with soil mask. For that, let's use the extract by mask tool. Extract by mask. Spatial analyst tool. Input raster soil, farm soil with our soil mask. Farm last. Save. OK. Done. If you also get that error or you cannot see the output, then there might be some changes in the settings of environment variables. So you can simply the easiest way is to use a new window, new template, and save changes, and there you can just input the required one like soil mask, and we have farm soil. Now let's perform the action again. Search for mask, extract by mask, input raster farm soil, and mask data is the soil mask. Save it to farm last, right? So farm last 2, let's call it 2, and OK. Yeah, this should work. Let's see if it worked or not. It did. We have successfully extracted our farm soil data using our mask. So that's how we can extract the other data as well. The remaining parts have been assigned no data value. Okay, now let's learn another thing. Here we can see many classifications. Now what if we just want to have ones and zeros values instead of this one? We can do that by classifying, which is called reclassifying. So reclassify tool, Spatial analyst, reclassify. We want to reclassify the formulas too, and if we had zeros, then we would call them zeros, but we have ones. We are going to call them all ones because these are all suitable land, so it's all going to be 1. Okay, it's all going to be 1 except for the no data. No data is, it's okay to leave the no data as no data. And after that, let's add the reclassified here. We'll call it form class, and click OK. This will reclassify as zeros and ones. So if we turn all layers off and just turn it on, then we can see just one class. If we had 0, then there would be 2 classes. That's how we reclassify in raster. So while reclassification, we can only enter integer values. That's something to keep in mind. Now what if we want to tell that ones are the plantable area and zeros are non-plantable areas? We can do that from attribute table and add text by using add field, and there we can write category, we have to start editing, call this category plantable. If we had 0 value, then I'm sorry, I should delete this field because by mistake I selected short integer. Instead I should have said it as text. Start editing, plantable, then stop, save editing. Okay, so that is how we classify. And then we can re-symbolize using category from properties, symbology, any values. Let's just remove, okay, using category. Okay, so plantable area. That's cool. Now we'll learn another thing, using zonal statistics to calculate area of plantable land. This is the 1.9 of our instruction of our manual. So let's follow these steps. Arc toolbox, Spatial analyst, Spatial analyst 2, zonal geometry as table. Let's classify using the value, and where do we want to save it? In output, right? Farm class geometry. I don't think it will take that long name. Let's see. Oh, okay, it worked. So what do we get here? Zonal geometry as table, that's what we did. So in the table we can get all the geometry. We can get the list of the area of each category, the area of plantable and non-plantable area. If there was another non-plantable area, then it would show that one as well. So that's what we have here. So that is the end of our lesson, of our tutorial. Now I hope to see you in the next video.